We're now going to move on to modeling with linear equations. So in the previous video we talked about solving linear equations with one variable. Now we're going to talk about modeling problems with these. Now some people don't like this section or this video because it's dealing with story problems. We're actually dividing this up into two videos. One is going to be just a basic review of the language and how to translate English sentences into mathematical expressions, and then we'll look at some examples where we actually solve some story problems. Now, my little personal thing about story problems is I believe they're incredibly important because the reality is, why do we learn math? Math is really a set of tools that we learn to help analyze problems in the real world. And that's one of the primary reasons, not the only reasons, but one of the primary reasons we learn about math. So if we're talking about tools to analyze problems, well, the problems we would be analyzing are story problems. Alright, so let's get back into modeling with linear equations. So let's first just do a quick review here of translating keywords / phrases into algebraic expressions. And we're going to go ahead, and there's five main things we're going to look for. We're going to look for equality, addition, subtraction, multiplication, and division. There's other things we could look at as well, but those are the first key ones we'll start looking at in this video. So equality. Well, we're all familiar with the symbol for equality. Symbol is simply the equal sign. But then what are the key words or phrases? Well, if the problem says equals, that would be an indication that you'd use the equal sign. Equals to, that'd be another key indication. But then there's some other words. Is, are, was, will be, represents. Now, this is not necessarily an exhaustive list, or this is not necessarily the only words, or that this is the only way you would ever use these words, but this is, if you see these words in a story problem, these are generally going to mean that you have an equal symbol. And then, of course, we'll move on to our operations. Our operations, of course, we said addition, subtraction, multiplication, and division. So we'll look at addition. Some of the key words you might say, of course, if you've added, that's going to be obvious keyword there. But as opposed to added, we also have sum, plus, increase by, more than, total of. Alright. Then, and of course I didn't put the symbol there, we all know what the plus symbol looks like. Subtraction. Well, difference, minus, less than. Now, when we say less than, we're talking about in a sentence here. We're not talking about an inequality. And when we look at some examples, you'll understand what we're referring to. Decreased by, subtracted from, reduced by. Now, I am going to give two examples here of this. I didn't do any for the sum because addition doesn't matter the order you do it in. But I am going to do a couple for subtraction because the order you subtract numbers greatly determines your answer. I mean, one case you might get a positive number, in the other case you might get a negative number. So let's first look at the difference. of 4 and 7. So the difference of 4 and 7 means you take the first number, 4, and then you subtract 7. So this is the order you would write it. Now it's important to notice that it's 4 comes first and then 7 comes second. Now you can't always say, oh, that's always going to be the case, because we can use different language. For instance, I could say 3 less than x. 3 less than x means you would actually put x first and you'd have x minus 3. So it's very important on the subtraction. There's a couple nuances you have to be careful with and make sure you put them in the correct order. Alright, so then let's go on to the other two. We have multiplication. And some of the key phrases we use for multiplication are product, multiplied by, which kind of is obvious, twice, which would refer to as 2 times, times itself, product of. Then finally we have division, and I'm not doing any examples with multiplication because again, multiplying in any order doesn't matter. So let's look at division. Quotient divided by ratio and per. Now the per one is a little bit unusual, but if you think about units, for instance, if you're thinking about velocity, for instance, you would have meters per second is how you would write this as far as the units for velocity. Well, wait, that's meters divided by seconds, meters per second. So per is actually a division. Okay, so let's look at a couple examples of this. So this, we're not solving any problems yet. We're just going to look at some algebraic expressions here. We're going to look at a sentence and then translate it to an algebraic expression. So let's talk about the perimeter of a rectangle with a width x and length twice the width. Okay, so this actually requires us to remember a little bit of geometry to write an expression down for this. So what do we have here? Well, I'm going to go ahead and just sketch a rectangle. And I'll try and make it somewhat representative of the problem. I'll let this be the width of the rectangle, and I'll let this be the length of the rectangle. And now we're wanting to do the perimeter. Now perimeter, remember, I'll write it as P is equal to the sum of the lengths of all sides. So since I've got this labeled here, I know that since this is a rectangle, this is also length W, and then this one down here is length L. So the perimeter here would simply be W plus L plus L, which is 2w plus 2l. But now we want to use this variable here. Well, what did they tell us here? We said the problem states that the width is equal to x. Width x, and then the length is twice the width. So the length is equal to twice, which is multiplication, the width, which would be equal to 2x. And so then we could rewrite my perimeter equation. That perimeter is equal to 2 times x, because that's what w is, plus 2 times 2x, because that's what L is. And then simplifying this, we'd simply get 6x. All right, let's look at one more here, maybe two more. Let's look at the product of two consecutive integers is 5. So we're going to write an expression or an equation down here. So let's first just think about this. Well, the product of two consecutive integers. Well, let's just go ahead and let x be my first integer, because I'm going to have some variables here. Well, consecutive means right after each other. So if x, for instance, was 7, you would have 7, and then the next consecutive integer would be 8. All right? So what we do to get a consecutive integer would simply be adding 1. So this is the consecutive integer. Now let's look for some of those key words here. We have a product, and I misspelled 2 here. Should be TWO. So we have product is 1, and then also, look here, is. So product means multiplication, so I'm going to multiply those. So my first integer is x, my second integer is x plus 1, and then is, well, is, remember, was an equal sign, 5. So I've got x times x plus 1 equals 5. Let's look at one more. Let's look at the sum of two consecutive odd, I apologize for that, my hand is hitting something. The sum of two consecutive odd integers is 8. Well, let's again look at some of the key words here. Sum, and we've got consecutive again, but notice that these are odd integers, and then we also have is. So let's go ahead and do variables again. So let's let x be the first odd integer, and then if I get another odd integer, well, what do you have to do when you count by odds? Well, you'd have 1, 3, 5, 7, so on and so on. So if you're counting by odds, you would need to add 2 to the previous number. So the consecutive odd integer would be x plus 2. This is the consecutive odd integer. And so what we'd have here is the sum. So the sum would be x plus, and I'll go ahead and put it in parentheses. The reason I'm going to do that is on the outside chance I have to do some kind of distribution, I want to make sure all my signs are correct. Now in this case it's adding, so everything would be positive, but I'm still going to do x plus the quantity x plus 2 is, so that's an equal sign. This is my first odd, this is my consecutive odd, is, and then what is it? 8. Now of course we could solve this equation that we've written down, but the point of this video has been to take these sentences here and translate them into algebra equations or expressions. The next video will actually talk about solving some of these story problems.